Hi everyone, so today we're going to be working on end behavior and graphing without our graphing calculator. So the first thing I want you to think about is we've talked about these as x approaches problems before. We usually talked about what happens as x approaches a number, and typically we were talking about vertical asymptotes. Now we're going to be talking about what if x approaches negative infinity or positive infinity. So to stick with me, we're going to try these four graphs here, and all you have to do is look at the picture. Okay, this is a negative x to the fourth graph. And it says as x approaches negative infinity. That means as x's get smaller, what's happening to the y values? The y values are going towards negative infinity. Okay, as I'll use red for the other one here. So as the x's go towards infinity, what's happening to my y values? My y values are getting smaller and smaller and smaller. So think of this almost as like left hand and right hand. On the left, it's going down towards negative infinity, and on the right it's going towards negative infinity. Okay, so same thing here. We've got a positive x to the fourth graph. As x's get smaller, so you're looking towards the left, what's the left end behavior? G of x is approaching positive infinity. Okay, versus when x's are getting bigger, as I go towards 10, 20, 100, whatever it may be, again, that's because the x values are getting bigger. In this case, actually, my y or g of x values are also going towards infinity. Okay, and what else we got, guys? Let's see. I've got two more graphs here, a little bit different. This one is a positive x cubed. And when I say positive, I mean this number is positive versus this was negative and this was positive. So just keeping that in account, we're going to need that in a minute. So a positive x cubed graph, as x's go towards negative infinity, okay, I used my teal here. As my x's get smaller, my y values are also getting smaller. All right, but as my x values get bigger, okay, think if you were to plug in 20, 100, 1 million, this would be a huge number, a huge positive. Okay, so it would go towards infinity. And last but not least, we have a negative cubed, x cubed graph. Okay, I just wanted to show you a different way of writing this. We're going to use it in calculus, and they're called limits. I just thought it'd be kind of fun to get a little quick preview here. This says the exact same thing as this, so it's just a quicker way of writing as x approaches negative infinity, what is the limit, or what is q of x approaching? So don't be intimidated. You don't need to know that necessarily. It's more just a quicker way of writing it. So as we approach negative infinity, for a negative x cubed graph, we're going up towards infinity as my x's get smaller. Okay, and as my x's get bigger, as the x values go this way, what's happening to my y values? They're going towards negative infinity. Okay, so let's take a look at what happened here, guys. End behavior is this word we're going to use, and I used it briefly. End behavior is what's happening on the left and what's happening on the right. We're also going to use this word turning points. Okay, turning points is a max or a min, so the total number of maxes and mins. When we talk about negative infinity and infinity, we're actually just going to use arrows, like up and down arrows, as you can see here. So let's go back and figure out what happened with each of these graphs, and I want to show you what I mean by turning points. So turning points would be any hills or valleys, so a maximum, a minimum, a maximum. So it says 3 turning points. I'll use TP for turning points here. This one, 1, 2, 3, max, min, or min, max, min is that one. So 3 turning points, okay. And then on number 3 here, you had a max and you had a min. So 2 turning points. And we had a min and a max, so 2 turning points. All right, so you'll notice also with the arrows, okay, we also had some information there. When we go towards negative infinity, we're pointing down. Okay, when we're going towards positive infinity, we're going up. So think of it this way. Instead of writing negative infinity and positive infinity, we're just going to be writing arrows. So when I ask you to sketch end behavior, you're just going to do up arrow or down arrow. So whenever it's infinity, you're going to put an up arrow, negative infinity, down arrow, positive infinity, up arrow, down arrow. Okay. You kind of wrote all the information we need. So what we're going to do is we're going to put this in a table below. Okay, so the 4 examples below in that table are representing the 4 problems we just did. So if you guys take a look with me here, I'll zoom out a little bit. We're talking about this table. All right, well, this degree, we could even not look at the graph yet. The highest degree is what you're looking for, right? So you scan, you make sure it's the highest degree. Okay, so the degree here is 4, 4, 3, and 3. Okay, I want you guys to notice the two examples given were x squared, which looks like this, and negative x squared, which looks like that. These are both degree of 2. They have one max or one min. Okay, and either we went up for those left and right end behaviors, aka infinity, infinity, or down, down, negative infinity, negative infinity. Okay, so that's what we're going to be doing for these. So take a look at number 1. Again, what did we notice about those turning points, guys? If I scan back here, 4th power had 3 turning points, 4th power had 3 turning points, 3rd power had 2, and this 3rd power also had 2. Okay, so we'll notice here I had 3, 3, 2, 2, 2 to 1, 2 to 1, 4 to 3, 4 to 3, 3 to 2. I hope you guys are noticing a function has at most n minus 1 or degree minus 1. I put n is equal to degree. N minus 1 turning points. So at the most, I'm going to have either, if it's a 4th power, it might not have 3, but it will at the most have 3 maxes or mins. If I have a 3rd power, I'm going to have at the most 2. If I had a 6th power, at the most I would have is 5. Okay, so turning points are 1 less than the degree. Okay, 1 less than, at the most, could be less than that. All right, and then end behavior. Let's see what's going on, guys. So take a look at those arrows you drew in. Okay, here we went down on the left. Okay, on the left end, use your left, pick up your left hand. On that side of the graph, we were down. On the right end, we were also down. So right hand, also down. So my end behavior for the first graph would be down, down, aka negative infinity, negative infinity. What happened with the next one? Let's see. We were up, and on the right side, also up. So up, up. All right, now these ones got a little more exciting. We went down, up. So left hand was down, right hand was up. And then for number 4, we were up on the left and down on the right. Up on the left, down on the right. Okay. So I want you guys to pause for a second. Let's see what we think. Sorry, I drew that really poorly. Okay, so my x to the 4th graph, and it was negative x to the 4th. I was down, down. My positive x to the 4th, I was up, up. Okay, so I want you to notice, first of all, with the 4th power, they were both the same type of arrows, either down, down, or up, up. And look at x squared. That actually is the same thing, right? I was up, up for positive x squared, and down, down for negative x squared. So for an even degree, so 2nd degree, 4th degree, 6th degree, if it's a positive, a is the leading coefficient, guys. So a would be like negative 2, 2, 1, negative 1. So when I talk about a being positive, I mean that leading coefficient. Okay, if a is positive, I have up, up behavior on both ends. I don't know what's happening in here. It depends on what degree it is. But in a general sense, it will end up, up. Okay, and if a is negative, so such as this example or this example, okay, if a is negative, I go down, down. All right, again, that'd be like the second graph where I went like this. It also could be a 6th power, like that. So they get a little more fancy looking as you go. And odd degree, what happened with those, guys? Well, when I had a 3rd degree, I went down to up when it was positive and up to down when it was negative. Okay, and this is going to hold for 3rd degree, 5th degree. It actually is true for a line, right? If I had a positive, like y equals x to the 1st power, I go technically down to up. If I have y equals negative x, looks like that, and I would go up to down. So if a is positive, it ends going towards positive infinity. That's what I always think of it as. And if a is negative, it begins towards positive, it ends towards going towards negative infinity, since it's negative in the front. Okay, so this would be like number 4. This one was like number 3. This one was like number 2. This one was like number 1 from above here. All right, so notice that odd degree have opposite arrows, odd, opposite, so that's easy to remember, even have the same, either up, up, or down, down. Okay, so take a look at number 5, which has 1, 2, 3, 4. I probably should have called those A, B, C, and D. But just to finish up here with number 5, and then we'll try this analyzing problem in class. We kind of bring this all together. All we're going to do here is determine the end behavior and the max number of turning points. So again, turning points, the maximum amount is going to be the degree minus 1. It might not be there might not be that many turning points, maxes and mins, but that's the most there could be. So again, turning points is the same thing as saying total maxes and mins. Okay. All right. So first of all, we look at this guy. This is a positive even degree, right? That's the top degree. So positive even. The end behavior would be up, up. And the max amount of, I'm going to use TP for turning points, would be 6 minus 1, so 5. And that's all you need to answer for these. All right, so how about this one? Negative odd power. Top power is a 5 here. So a negative odd, go up here. Okay, negative odd would be up, and it ends going towards negative infinity. And turning points would be 5, top degree minus 1, so 4. All right, and how about number 3 here? Negative 3x to the 4th, so negative, and then it's an even power. So negative even is down, down. Turning points, 1 less than the degree is 4, so turning points at the most 3. Okay, and number 7, positive leading coefficient. It's an odd power, 7th power, so down to up. That would be this right here. Okay, and that's our end. So if I say sketch the end behavior, this is all I need from you guys. It's just 2 arrows, the correct arrows. And turning points would be 7 minus 1, which is 6. So at most, this graph is going to have 1, 2, 3, 4, 5, 6 turning points. So it could look something like that with 6 maxes and mins total. Okay, so that's what we're looking for here. Again, end behavior is talking about what happens on the left-hand side. Use your left hand. And then the other arrows, what's happening on the right-hand side. How's it trending when it goes towards infinity or negative infinity. Okay, and that's about it. So make sure you feel comfortable with this especially, as well as how many turning points you could have. Like I said, we're going to bring this all together, so you could even have a preview. We're going to do synthetic division, of course. Then we're going to draw a diagram of the end behavior, and then we're going to use that to pick which graph would this look like. So even though we're not going to graph completely right now, we should be able to use end behavior and other information to figure out which graph matches this polynomial. All right, so thanks for watching, and please bring in any questions.